Hello friends, in today's video I will be talking on some of the engineering mechanisms like gears, the springs, the chain drive, that is chain, and the sprocket assembly, and the belt drive, that is belt and the pulley assembly, and their applications. So in today's video what we are going to learn is what are the different functions of the different mechanisms and the equipments or the devices and the applications of various mechanisms. So let's begin. First one is the pump. We all know what the pump is and what is the function of the pump is. So here you see a schematic diagram of a centrifugal pump where this circular thing we call it as an impeller. It's kind of a disc having number of blades attached on it, and this is the shaft on which this disc is attached. So when the shaft will rotate, the disc will also starts to rotate. So this thing is the casing where two pipes are attached to it. One is this inlet pipe and this one is outlet pipe or delivery pipe. So here we have the water reservoir, which we generally call it as a sump. So here the task is to lift the water from the sump to this delivery tank. So you can see the water, we have to lift it from the lower level to the higher level. So when we turn on the pump, then this impeller starts rotating, which is going to create the pressure difference across the inlet pipe and the outlet pipe. So pressure here will be less, and due to the less pressure than the atmospheric pressure which is acting at the surface of this sump, so here the pressure acting is an atmospheric pressure, and when the impeller starts rotating, it sends the air to the delivery side, or in short, here a vacuum will get created, that is low pressure zone will get created when we starts an uh, pump. When we starts the pump, the low pressure zone gets created over here, and the water flows from the higher pressure, that is atmospheric pressure, to the lower pressure. The moment the water reaches here, then this impeller provides some velocity to the water, and it causes the increase in the pressure as well, and due to that high velocity and high pressure, the water gets delivered to this delivery side through this delivery pipe. So this is what the basic principle of the centrifugal pump. The main motto here is to understand what is the function of the pump and what is the principle of working of the pump. However, there are a lot of different types of the pumps available in market, like this one, which is centrifugal pump, then another is a reciprocating pump, then gear pump, the screw pump. So each pump has the different applications. So here let's understand that the function of the pump is to lift something from one location and deliver it to the other location, whether it is a liquid or whether it is a semi solid, like slurries are there, which so for that we use a gear pump or the screw pump. Screw pump is also used to deliver the oil to the engine jacket for circulation of oil within the engine jacket, so that oil can remove the heat from the engine and reject that heat to the surrounding, something like that. So in pump, the principle is to create the pressure difference, and due to that pressure difference, the water flows from, water means any liquid flows from a low pressure zone to the high pressure zone. So that's it. So here you can see this is the casing of the centrifugal pump. We call it, this one is a eye of an impeller, the center portion of an impeller. So this is a casing. Within this casing we have an impeller, and here the water gets enter from the sump, that is from the lower level. It enters here at the eye of the impeller. Impeller starts rotating, and it delivers that water to the delivery side, which is over here. So delivery pipe is connected over here, inlet pipe is connected over here, and the water flows from the center to the upside. So what makes this impeller? So this was the pump, this is the pump, and impeller runs within the casing. So what makes this impeller to rotate is this bigger motor. So the shaft of the impeller is connected to the shaft of the motor. So when you turn on this whole assembly, and actually the pump uh, starts just because of starting of the motor. So motor gets started, and that drives the impeller, and hence the pump works. So what are the different applications of the pump? Let's see. So hand pump, which is a general example of reciprocating pump. Here we all know that the water which is in a bore well, we lift that water from the well and we gets collected here onto the ground with the help of this hand pump. Then the petrol pump, in a petrol pump also the petrol reservoir is located underground, and we lift that petrol to get filled in our tank with the help of the pump. Then in water refineries, in some food processing industry, to transfer the liquid from one location to another location, or yeah, something like that. In boilers also, to circulate the water, to deliver the water. Boiler means a thing which we use to convert the water into the steam. So we need to supply the water to the boiler continuously, and in a boiler, with the help of heat, the water gets converted into the steam. So we need to supply water continuously to the boiler under some pressure. So in that case also we use the pump. So a lot of applications are there, so I am stating here a few important applications. Now let's move on to the next device, which we call it as a compressor. You can see the diagram. So this is again the schematic diagram where we have this piston which reciprocates within this cylinder up and the down. It has two valves, one is inlet valve and second one is delivery valve. So what comes in an inlet valve is the air, what gets delivered is obviously an air, but with some higher pressure. So the name itself tells that the function of this device is to compress an air. So how it happens, let's take a short look on it. So just imagine that this piston is at this topmost position. Technically we call somewhere here the maximum position of the piston where it can reach, and somewhere here let's say that this one is a position of the piston, and we call it as a top dead center, technically TDC, top dead center. Okay, so here is a top dead center. So just imagine the piston is, just imagine this piston is here at the top dead center and it is moving in downward direction. So what is going to happen here, I will explain this in short, not in too much detail. What is happening here, when piston moves from this top dead center to the bottom dead center, during this travel, what we are having at this within this cylinder is the residual air, means remaining air of the previous moment, right? So here when the piston is moving from top dead center towards the bottom dead center, let's say somewhere here is the bottommost position of the piston where it can reach, and we call it as a bottom dead center. So in short, the piston is traveling from the top dead center to the bottom dead center, up and down. It is reciprocating between the TDC and the BDC, and the travel of the piston from TDC to BDC, technically we call it as a stroke. So we can now say that during this travel of the piston, that means during the stroke of the piston from TDC to BDC, the vacuum gets created over here, little bit vacuum gets created over here because volume is increasing. You can see piston is going down and down, so the volume within the cylinder is increasing, and it will affect the pressure within the cylinder also, which will decrease. So pressure is decreasing. So when the pressure within the cylinder falls below the atmospheric pressure, so here we have an atmosphere and here pressure is atmospheric. So when the pressure within the cylinder falls below the atmospheric pressure, then this inlet valve will get open. This inlet valve is pressure differential kind of a valve. It will get open and close automatically due to the pressure difference across it. So here at this side the pressure is high, here the pressure is low, so inlet valve will get open, which will allow an air to get sucked within the cylinder. So this will continue to happen until piston reaches to this top dead center position here. The moment piston reach at BDC, bottom dead center, then it will move towards the top dead center position, up and and during that what will happen, air is already here of previous stroke. Now that air will get pressurized as piston is moving up, and this will create a pressure difference. Now pressure over here within the cylinder is higher than the atmospheric pressure, so inlet valve will get closed this time. And when pressure reaches beyond the delivery side pressure, so here is a delivery pipe, so here some pressure is there which is obviously higher than the atmospheric pressure. That is what the function of the compressor, to get the high pressure air, to provide the high pressure air than the atmospheric pressure. So here onto the delivery side we have some pressure, higher pressure. So when the pressure within the cylinder during the travel of the piston from BDC to TDC, when pressure within the cylinder reaches more than the delivery side pressure, then this delivery valve will open and the high pressure air gets supplied to the delivery side, right? So how this piston is reciprocating? So for that we have the mechanism of crank and connecting rod. So this connecting rod is connected to the piston, so one end of the connecting rod is connected to this piston and another end is connected to the crank here with the help of a pin, and this crank is connected to this shaft which is called as a crankshaft. So again here we need to take an input from the motor. So shaft of the motor is connected to the shaft of this compressor. When we turn on the motor shaft starts rotating, and hence this crank starts rotating, and due to this mechanism of connecting rod and the crank, when this crank is rotating, then this piston starts reciprocating. So this is how simple mechanism it has, which causes the motion of the piston from TDC to BDC, and that causes the pressure difference across the valve, which helps in suction of the air within the piston and then delivery of the high pressure air to the delivery side. And then we store that high pressure air in a tank, and then we utilize that high pressure air wherever we need it. So let's see what are the different applications of the compressor. So you might have seen at air station or in a service stations of the vehicle this kind of a device. So this blue color tank is nothing but the receiver tank which stores the high pressure air. So the delivery side gets connected over here, so it delivery side of the compressor is connected to this end, and then high pressure air is stored here. I'm sorry, this is not a delivery side, actually this is what the what we can say, this one is the delivery side only, but from this tank we deliver that air to the thing where we need that air, right? So here we attach a pipe, and then the air from this tank gets delivered to the station where we need it. So here these are the compressor, one is here, second one is here. So this is a twin compressor, V in a shape. This one is motor which drives this compressor. So motor is not directly connected to the compressor, but it needs a belt drive which you can see at the rear side of it, black in the color. which causes the speed reduction. So motor drives the compressor. Compressor compresses the air. That air gets stored in the tank, and then we utilize that air at a service station. So for filling an air in a tubes of tire, we use this kind of a compressor. Then this one is the diagram of the refrigerator. So it also needs a compressor. Here you can see the position of the compressor in the diagram. Here the actual compressor, which is located at the bottom of the refrigerator. It compresses the refrigerant, which is the working fluid within the refrigerator. Similarly, an AC also needs a compressor. The components which are generally we see or we have in a refrigerator, almost same components we have in a AC also, because both of them gives us a cooling effect. Then this one is a small size compressor over here, and this is the tube through which we get the high pressurized air, and here this is the vessel or the container which we filled with paint, and then we use that air to paint the thing, whether it is wall or whether it is any body part, whatever it is, body part of a car or anything. So in a spray painting we use the compressor. A lot of applications are there for a compressor. I have stated the important one. Now let's move on to the third thing, which is the spring. So you can see here the different types of the springs we are having. So according to the requirement, we have different types of the spring for use. Like helical compression spring, we have it here. Helical extension spring, you might have seen in the weight measurement. For weight measurement purpose, you use this kind of a spring. Then this is a conical spring, torsional spring. Then this is called as a bilevel spring. Then lip spring. So this is the most common type of the spring which we know it very well. And this one also you might have seen. We use this kind of a spring. I'm sorry. We use this kind of a spring for suspension purpose in trucks. I'm sorry. So let's see. So what is the basic function of the spring? We know that when we can compress the spring or we can elongate the spring. When we compress the spring by applying some force on it, then it stores that energy which we have used to compress it. The moment we remove the load, then it decompresses. That means it supplies that energy which we have been used to compress it. After removal of the force, that energy the spring delivers back just by uncompressing or decompressing or by elongating. So here this is the spring which is used in this shock absorber. In case of this bike, we use the spring for shock absorber for suspension system in cars also, in trucks and the buses also. But the spring which we use in buses or the heavy vehicle is a lift spring, which I have shown you here. So this is a different kind of a spring, and this is called as a helical spring. So when your vehicle passes a pothole or any rough surface on the road or the speed breaker or any kind of a bump, then that is what the sudden load which gets act onto the spring gets compressed, it stores that energy, and then it delivers that energy back just by elongating, by coming to its original position. One more thing is there which is called as a damper, but we will not go into that detail. For now you just remember that the spring has this one of the most common application in the vehicle, that is in suspension system. Then in clocks also we have very small miniature kind of a springs. Then in the paints, this is kind of a door retainer which will bring the door into the closed position without applying any force by the human being. When you open it, you have to apply the force, but you no need to do anything to make it close because of this thing which is called as the door retainer, this black one. Here you can see this black one. This is called as a door retainer, which will bring this door back to its closed position, just obviously with the help of the spring. This is what happening over here. Then in the door levers also we have the spring, so this kind of a latch is there, so you can push it in and it automatically comes out just because of the spring. Next is the gear. So we all know the gear. So gears we use for two purposes: to transmit the motion from one location to another, as well as to have the different speed. For an example, let's say here this one is the gearbox of an automobile. So this one is a shaft, so this shaft is rotating at a one speed. If you want to, and when the shaft rotates, this shaft will also rotate. So let's call it as an output shaft. This is an input shaft. So when this shaft will rotate, this shaft will rotate, and this will happen just because of the connection of the gears. And when we want to make this output shaft to rotate at a higher or the lower speed, then we shift the gears. So this is a shifting mechanism. We shift the gears. Here you can see that we have the gears of a different diameters. So when we change the gears diameters, then the output speed will also change. So for example, if the input diameter gear and the output diameter gears are same, then in that case you can imagine when this input shaft is rotating at 100 rpm, this output shaft will also rotate at same rpm. Rpm means revolutions per minute. So in other case, if this input gear is of a bigger size and the output gear is of a smaller size, then you can see that when this input gear will take one revolution, this output gear will take more than one. That means in that case this output shaft will rotate at a higher speed than the input shaft. So that's how we can increase the speed or decrease the speed of the output shaft just by engaging the different pairs of the gears having a different sizes. Here also you can see that this one is the thing in which is the printer, and these are the gears which are used in a printer, but the difference is of a material. Here the material is a plastic kind of thing. So you can see the different sizes of the gears are there, which will give you the different speed at their shafts just because of the difference in the diameter. This one is a huge gear, which is gear of a wind turbine, that is windmill. This is a gear from the crane, overhead cranes, which we use to lift something which is very heavy, and we lift it and then we place it back or place it at some other location. So this is all about the applications of the gear. In next video I will be talking on the belts and their application, the valves and their application, the levers and their application, and then blowers and their application. Till then, I am Manoj Sonone signing off. Have a good day.